Hey, have you ever considered adding a dash to your Unity game? In this video, I'll show you how it's done. Dashing is one of the most popular game mechanics in the history of video games, confirming its enjoyment value for players. A dashing mechanic is relevant for both 2D games like Celeste and 3D games like Overwatch, which has characters like Genji who has a dashing ability. So it makes sense that you want to add it to your game. The implementation that I'll show you works for both 2D and 3D games, but for this demonstration I have a 2D project set up, but you can easily use the same classes and simply adjust them to fit 3D instead. Let's dive into it. Whenever I start creating a new mechanic for any of my games, I first make a list of what I need in order for the functionality to work the way I want it. This is a good practice to do every time you want to implement something new to your game. So what do we need then? First of all, we need a method to perform the dash and to freeze the player. This will include a dash force and a dash direction to see how powerful and in which direction the dash should be performed. Then a dash counter to store how many times you've dashed to limit the method from being used more than once. A dash time to set how long the dash is going to last. And then a way to freeze the player's movement and Y value so that the dash is straight and consistent. And lastly, to enable the effects and sound. The second part of the mechanic is all about enabling the player movement again after the dash and stopping the effects. An easy way to do this is to set up a new method that we can invoke from the dash method within a set time. And now, when we have all this written down, we can start transferring our ideas into actual code and components in our project. Now, this is a prototype of a 2D platformer that I will use as an example for the dash. It already has basic functionality for the player to move, jump, and so on. I'll write the whole movement class of the character down below so you can see it properly. But what's most important with our already implemented functionality is that we have a ground check to see if the character is on the ground and that the player can move, preferably with a horizontal input like this. You can use this dash technique without this exact implementation, but the code will look slightly different when we check for in which direction we want to dash in. Anyways, let's start setting this up. First of all, let's attach a TrailRenderer component to our player. Set the time to 0.2 and then the mean vertex distance to 0.1. Then you can adjust these values to 0.5 and around 0.2. You can customize the color in any way that you like, but I like to set the color to a transparent white with extra transparency at the edges to make it smoother. And then you need to change the material into something simple and white for the color to work in the way that you want it. And lastly, we want to turn off the emission by default since we want to control it from the script instead. Then we need to go into the player movement script and add a reference to the TrailRenderer that's accessible from the inspector window. You can do this by writing serialized field, private, TrailRenderer, TrailRenderer. Then you can save it and then you can simply drag the component into the slot in the player movement script in the inspector. Now, let's write the code related to the dash mechanic. First, we need to declare some variables from our list that we wrote earlier. And these variables will store information about the dash force, the dash counter, and the duration of the dash. Write private float, dash force, and set it to 25. And this will control how powerful the dash is. You will probably need to adjust these values in order for it to fit your specific game. And you can do that by writing serialized field and then just play around with the number in the inspector. But for now we can just set it to 25. Then we will add a private int dash counter and set it to 0 to limit the number of dashes. And then add a private float dash time and set it to 0.2 to set the duration of the dash. Now, let's create the dash method. This method will handle the actual dashing action, playing the dash sound, and freezing the player's vertical position and setting the player's velocity for the dash. First, we increment the dash counter by writing dash counter plus plus. Then we disable the player movement by writing can move equals false. And this is a bool that we have declared earlier in the class to limit the player's movement input when moving is not allowed, like when the player is dead or like in this example when the player is performing a dash. Then we freeze the player's vertical position by writing rb.constraints, rigid body constraints to d.freezePositionY. Then we calculate the dash direction and then add .normalize to the vector to make sure that the value is always 1 when we later calculate the dash velocity. We do this by writing vector2 dash direction equals new vector2 horizontal value 0.normalized. Then we set the player's velocity for the dash by writing rb.velocity equals dash direction times dash force. And then lastly, we enable the TrailRenderer to show the dash effect by writing TrailRenderer.emitting equals true. And then of course we need to add a sound effect and then also a trigger for the animator. And then after the dash is initiated, we need to re-enable the player's movement again and then stop the TrailRenderer effect. We will do this in a new enable character move method. First off, we can write TrailRenderer.emitting equals false, which will disable the TrailRenderer effect. And then we can add CamMove equals true, which will allow the player to move again after the dash. To unfreeze the player's vertical position, we add rb.constraints and equals rigid body constraints to d.freezePositionY. And then of course we need to remember to invoke the enable character move method from the dash method within our pre-decided dash time. Now, let's update our update method to include the dash functionality. We'll check if the player can dash and if the necessary conditions are met before calling it. We do this by writing if CanMove and check if grounded is false and the dash counter is smaller than 1 and the key S is pressed and the horizontal value is not equal to 0. Lastly, we can go to our check if grounded method and write dash counter equals 0 in order to reset the dash limitation every time we touch the ground. Now, let's demonstrate the dash in our game scene. As you can see, a simple but elegant dash mechanic that works exactly how we want. You can play around with the values to fit your games more specifically. For example, you can make the dash longer or increase the dash limitation so that you can dash more than once at a time. And there you have it. That's how you can implement a dash mechanic in your Unity game. The whole player movement class will be found in the comment section down below. Thanks for watching and see you next time.